In this example, we're given that PQ is parallel to RS. It doesn't appear here, so what I'm going to do is write that down in our first couple steps, and that's going to be given to us. We can see those marks are here, PQ and RS. If not, we'd want to put those marks in ourselves. We're also given that angle PRQ, which is this angle, is congruent to SQR, which is this angle, and that also is marked on the diagram. Notice how that was just given to us. It's in the given section, so the reason is just that it's given. We're asked to prove that triangle PQR is congruent to SRQ. To do that, we need to use one of the postulates to prove that those are congruent. And if we think about this right now, we have a reason here that alternate angles are congruent. And if I look at these parallel lines here, I'm just going to kind of elongate those a little bit. So these are line segments, but you can imagine them as being lines, I suppose. And then here's a transversal. And if we look at this transversal, we have this angle here and this angle here, and those two angles are going to be congruent because alternate interior angles are congruent. And you can see here that they are on alternate sides of the transversal, and they're on the inside or the interior of the parallel lines if you look here. So now we just have to name these. Well, one angle is angle PQR. So we'll write angle PQR. Our congruent symbol, notice the word congruent, and then we're going to do, you could do QRS or SRQ, either way. Now we've accurately named the angles that we are allowed to state are congruent using the alternate interior angles theorem, which states that alternate interior angles are congruent. The next one, RQ is congruent to RQ. Well, this is an easy one. Whenever you have an angle or a segment congruent to itself, this is the reflexive property. So you can just write that in there as your reason. Well, that's not marked here, so let's mark it. RQ is congruent to RQ. You can put one tick mark. If you want to put two, that's fine. Either way is okay. Let's look at how we're able to prove that PQR and SRQ, rather, are congruent. So if we look at these two triangles, we have angle, side, angle, and angle, side, angle in common between the two of them. So this one is going to be angle, side, angle. Notice this side is included between the angles, and so it appears that way when we write our three-letter shorthand for angle, side, angle.